Hello and welcome once again to the Aakash BYJU'S JEE channel. My name is Atiullah and a very warm welcome to the Rankers Batch 2023. So if you want to be a ranker in JEE Main and Advanced 2023, then this is the place to be. So on agenda today is relative motion, and this is lecture 3 of relative motion. So if you have missed the previous lectures, you can always go to the Aakash BYJU'S JEE channel, search for the playlist Rankers Physics, and there you're going to see all the videos. Alright, so what we're going to discuss today is condition for collision. If two particles are colliding, what is the condition for collision? And some beautiful problems can be framed on this topic, and there has been some very good problems on this topic in previous year competitive exams. So a very important topic, a very scoring topic, and a very interesting topic as well. So we are going to discuss that. So if everyone is ready, if you're all set to go, quickly give me a thumbs up, quickly give me a yes, so that we can start with this session. We can get rolling. Alright, so before we begin, a few announcements. You would have heard of ANTHE, so if you know someone who is between class 7th and 12th, tell them about ANTHE. If they do well in this exam, they can win a lot of rewards, which includes an all-expense paid trip to NASA, 100% scholarship, cash rewards, and a chance to be an all-India rank holder. Also, you can check out the Aakash BYJU'S app. So it is free for 14 days and you can check the content over there. It's very nice content. It's top-notch content. So do check it out. All right. So all announcements done. Everyone ready? So if everyone is ready, we can get started with this session. So there are two things we are going to look at. First is the condition for collision. Okay, so if two particles are colliding, when would they collide? And if they are not colliding, then we can find the distance of closest approach, which is the second thing on our agenda today. Alright, so if all is set, let's get started with this session. Alright, so let's say we have two particles A and B and they are going to collide. We know for sure that they are going to collide, and this is happening, let's say, in a horizontal plane. So both the particles do not have any acceleration, okay? They do not have any acceleration. So what we're going to observe is that, let's say, A is moving in this direction and B is moving in this direction. So we know for sure that they are going to collide. But what we are interested in is that how would it appear to A? If we put a camera on A, what would the camera observe? Now think about it, okay? Now we know that there is no relative acceleration, okay? What do we know? There is no relative acceleration. So the relative velocity of B with respect to A is going to be a constant. And if that is going to be a constant, then we know that the trajectory of the path taken would be a straight line. Is that right? So we know for sure that if we observe this from the frame of A, the relative velocity is constant and hence the trajectory is going to be a straight line. Now what would A see? A would see that B is over here. Okay, when A is over here, B would say that A would say that B is over here. So that is the initial position of A. That is the initial position of B. And we know that it is finally going to overlap with A. It is finally going to hit A, which means the position of A and B is going to be the same. So A is going to observe that B is going straight and hitting A, because A's motion according to A will not be there. Okay, in the frame of A is not moving. So what A will observe is that this particle B is directly headed towards it. It is going straight towards it and it is hitting it. Okay, so at all points in its journey, A will observe that B is headed straight towards it. So what do we infer from here? That the relative velocity of B with respect to A will always be in the direction of the line joining the two particles, and this is a very important concept. Okay, so we can write this mathematically as well. Okay, how can we write this mathematically? We can say that the relative velocity vector VB minus VA, okay, and we want to take the magnitude and divide it by that. What do I mean? I mean the unit vector of the relative velocity. Okay, the unit vector of the relative velocity should be in what direction? It should be in the direction of their initial position. Okay, so what is this? I can write it as RB minus RA, and I'm going to divide it by the mod, so that we get unit vectors on both sides. Okay, so this is a very important thing to remember. And what is the crux of this concept? The crux of this concept is that if two particles are going to collide, and remember, there has to be no relative acceleration. Relative acceleration is not allowed. Okay, so if two particles are going to collide and they do not have a relative acceleration, then their relative velocity will be in the direction of their initial relative position, or their relative velocity would be in the direction of the line joining the two particles. And using this concept, this simple concept, we can solve many questions. Okay, so it is going to save us a lot of time and effort to use this concept. Otherwise, if we go by the general route, if we go by the standard solution, it is going to be a little more tedious. So using this concept, you can solve questions much faster. And there have been so many questions in the previous years on this topic. This is another of JEE's favorite topic. I cannot see the comments. Is it the right channel? Yeah. All right, let's start with this question. Okay, what is this question? On a frictionless horizontal surface, assumed to be XY plane. Okay, this is a frictionless horizontal surface. So the plane of the screen is the horizontal plane. Okay, and we are taking X and Y in this particular direction. A small trolley A is moving along a straight line parallel to the y-axis. You can see this small trolley. This is moving with a velocity of √3 minus 1 meter per second along the y-axis, or parallel to the y-axis. Now at a particular instant, when the line joining OA, this is O, this is A, the line joining OA makes an angle of 45 degree with the x-axis, a ball is thrown. A ball is thrown along the surface from the origin O. Okay, so from here a ball is thrown. Its velocity makes an angle phi with the x-axis and it hits the trolley. Okay, so the actual velocity of this ball, it makes an angle of 45 degree with the x-axis, and then we know that there is going to be a collision. Is that correct? So are all the conditions satisfied for collision? What is the condition? That both the particles have constant velocities, there is no relative acceleration. And if there is no relative acceleration, then we can say that if two bodies are colliding, then their relative velocity is going to be along the line joining the two particles. Is that correct? Okay. So now what do we have to find out? A, what is it that we have to find out? We have to find out that the motion of the ball is observed from the frame of the trolley. Okay, the motion is observed from the frame of the trolley. Calculate the angle theta made by the velocity vector of the ball with the x-axis in this frame. So basically what are we asking? That we are now in this trolley A and we are observing this ball from trolley A. So what is the frame now? The frame is trolley A. The trolley A is itself moving. So we are in the frame of trolley A and we have to tell that what will be the direction of the relative velocity of the ball with respect to trolley A. Is that correct? Okay, so we have to tell that whatever will be the angle made by the relative velocity vector with the x-axis, that is the angle that we need. Is that correct? Okay, and that angle is called theta. So we have to find theta. Okay. Now we already know that both the particles are going to collide, and if both the particles are going to collide, what will be the direction of relative velocity? The relative velocity, I'm calling it the velocity of O, or velocity of the ball with respect to A. So the velocity of the ball with respect to A is going to be along the line joining the two particles. Is that correct? Which means that theta in this case is going to be what? Theta is going to be 45 degree. Is that correct? Okay. So such an easy way to solve this question. Otherwise, if you would use 2D motion, in the ground frame, it is going to be very tedious. Okay, so just by this simple concept, we can say that theta is going to be 45 degree because the relative velocity is going to be along the line joining the two particles. All right, next. What is the next thing we need to find out? We need to find out the speed of the ball with respect to the surface if phi, this is going to be phi. Phi is equal to 4 theta by 3. Okay, so we have already calculated theta, that is 45 degree. Now the ball is actually thrown from the ground frame. Now from where are we talking about? We are talking about the motion from the ground frame. From the ground frame, it is observed that this ball is thrown at an angle of 45 degree. Okay, so what is this? This is the velocity of the ball with respect to the ground. Is that correct? Velocity of the ball with respect to the ground. And what do we have over here? We have the velocity. This is the velocity of the trolley A with respect to the ground. What do we need to find out over here? What do we need to find out here? We need to find out what is the velocity of the ball with respect to ground. Is that correct? Okay. So in order to solve this question, again, if we are able to draw the relative velocity triangle, we have discussed relative velocity triangle in the past. So in this case, if we are able to draw the relative velocity triangle, then our job is done, isn't it? So let's try to draw the relative velocity triangle. Okay. Now we know for sure that this is the velocity of A or the trolley with respect to the ground. Okay. From here, this is the velocity of ball B with respect to the ground. And what is this? This is the velocity of ball B with respect to A. Now you would ask, how do I know that? How do I know that? I'm going to show you again. Let's forget about this for a moment. Now I know for sure that the velocity of A with respect to the ground is this. I also know that the velocity of ball B with respect to A is going to be along the line joining the two particles. So I have made this vector. And what is velocity of the ball with respect to ground? It is velocity of the ball with respect to A plus velocity of A with respect to the ground. So velocity of the ball with respect to the ground is a vector summation of these two vectors. So that is going to be over here. This will be the velocity of the ball with respect to the ground. Is that correct? Okay. Now what are these angles? Can we quickly look at the angles? What are these angles? This angle over here is 45 degree. This entire angle over here is 60 degree. Okay, because we know that phi is equal to 4 upon 3 into 45, which is going to give us 60 degree. Correct? Okay. Now what is it that we need to find out? We need to find out this length, right? That is the velocity of the ball with respect to the ground. So how do we do that? Now let's look at this smaller triangle. Okay, let's look at this smaller triangle. So this is going to be 90 degree. So this is going to be 45 degree, which means that the distance here is going to be the same as the distance here because it is going to make an isosceles triangle. Okay, so both these distances are going to be equal. Okay. All right. Next, what do we have? Can I say that this distance over here, and I'm asking you to look at the bigger triangle. I'm asking you to look at the bigger triangle. And what is the bigger triangle saying? The bigger triangle is saying that this distance is VBG cos 60 degree. Okay, just look at the bigger triangle. Then this base is going to be VBG cos 60 degree. Okay. And what is this going to be? This is going to be VB sin 60 degree. VBG sin 60 degree. So what is this length going to be? This length is going to be VAG minus, this is going to be VBG sin 60 degree minus VAG. Is that correct? Okay, so what are we looking at? We are looking at this. This velocity is going to be VBG sin 60 degree minus VAG. Is that correct? Okay. So what do we know from here? We know that the two distances that we have calculated are going to be equal because they are part of the isosceles triangle. Correct? So we can say that VBG cos 60 degree should be equal to VBG sin 60 degree minus VAG. And what is VAG? It is root 3 minus 1. Okay. So now we take VBG cos 60 degree on the other side. We take root 3 minus 1 on the other side. So we are going to get root 3 minus 1 is equal to, now we can substitute like this, VBG, and this is going to be sine 60 degree, meaning root 3 divided by 2 minus, we'll have VBG cos 60 degree, and cos 60 degree is half. So if we take 2 common, root 3 minus 1 on both sides will get cancelled. So we will get the answer VBG is equal to 2 meter per second, and that is going to be our answer. Is that correct? Is this clear? Alright, so this is part B of the question. Is this the right YouTube link? Because there are no, I cannot see chats. Just check if this is the right YouTube link. Just hold on, guys. I'm not able to see the chat. So just hold on for a second. What is the title?
Is coming there?
It is coming there, but I can, there are no chats at all.
Students are less.
Alright.
This right.
What is the title of the video? I'm just asking, what is the title of the video? What YouTube video? What is the title of the video?
JEE Mains 2023.
No, this is Rankers. This is Rankers 2023.
This the schedule. Yeah. 12:30. 12:30.
Sure, what is the title? Condition for collision? You see that? That's the title?
Yeah.
Okay. Alright, so let's move on. So let's look at this question. Now ball 1 is thrown towards a tower at an angle of 60 degree with the horizontal with unknown speed u. Okay, so it is thrown at an angle of 60 degree with unknown speed u. At the same moment, ball 2 is released from the top of the tower as shown. Okay. Now balls collide after 2 seconds, and at the moment of collision, the velocity of ball 1 is horizontal. Okay, so this is released from the top, they collide after 2 seconds, and it is known that the first ball, it will have a velocity which is horizontal. At the time of collision, it has a velocity which is horizontal. So what are the things we have to find out? We have to find out what is the speed u. We have to find out what is the distance of point of projection of ball 1 from the base of the tower, which means we need to find this out, and we also need to find out what is the height of the tower. Okay, so let's solve this one by one. So let's get started. Okay, first of all, what do we need? We need what is the speed u. How do we know what is the speed u? Okay, very simple. It's a simple projectile motion concept. At this point, the velocity is horizontal, which means this is the maximum height achieved. Okay, and maximum height achieved is at half the time period. Do you agree? So what, the maximum height achieved is at half the time of flight. So what is the time of flight? 2u sine theta by g. So half time flight is going to be u sine theta divided by g. And this is given to us as 2 seconds. Is that right? So from here you can find what is the value of u. So u will be equal to 2 multiplied by g, which we can take as 10, and then sine 60 degree. Sine 60 degree is going to be root 3 divided by 2. So this comes out to be 40 upon root 3 meter per second. Okay. So we have found out what is the velocity. What is the velocity of this? Let's call this first particle. Let's call this second particle. Alright, so first part of the job is done. So now let's look at the next part of the job. We want to find out what is the distance of point of projection, meaning we want to find out this distance x. Now what is this distance x? This is simply the horizontal displacement. Do you agree? This is simply the horizontal displacement. And the horizontal displacement is going to be the horizontal velocity, What is the horizontal velocity? It is u cos 60 degree. Is that correct? Multiplied by the time taken. And what is the time taken? The time taken is 2. So this becomes 40 upon root 3. Okay, so let me check if this is 40 upon root 3. Yes, so this is 40 upon root 3. And then cos 60 degree is half multiplied by 2, which gives us the value of x as 40 divided by root 3 meter. Is that correct? Okay, so this is going to be the value of x. Okay, distance of the point of projection of ball 1 from the base of the tower. So we have figured out what is x. Is that correct? Okay. Now what do we need to find out? We need to find out what is the height of the tower. Alright, so let's try to figure out what is the height of the tower. Now we can do it from the ground frame as well, and we can do it from the relative frame also. But first let's try to do it from the ground frame. From the ground frame we can say that this is going to be h max for the projectile. Okay, for first particle this is going to be the maximum height reached, and for the second particle this is the displacement in 2 seconds. So when we add those up, we can find what is h, and we already know what is the time. Okay, what is the time taken? So that's not difficult to calculate at all. Okay, so let's first try to find out what is h max. H max is going to be u square sine square theta divided by 2g. Okay, so let's substitute. So u square is going to be 40 by root 3 square, which means 40 multiplied by 40, and root 3 square is going to be 3. Then we have sine square 60 degree. So sine 60 degree is root 3 by 2. So squaring that is going to give us 3 by 4. And then we can divide it by 2, and g we can take it as 10. So 40 and this 40 is gone. This 3 and this 3 is gone. So this gives us 20 meter. Is that correct? Okay. So the maximum height reached by the first projectile is 20 meter. Now let's talk about the second particle. The second particle is released. Okay, the second particle is just released. If the second particle is released, then its displacement is simply going to be half gt square. So this is going to be half into 10 into what is t square? T square is 4. So this gives us 20 meter, which means that the height of the tower is going to be h max plus h, which is 40 meter. Is that correct? Okay, so this we have solved from the ground frame. But what is the use of learning a concept if we are not applying it? Okay, so what I want to do is, I want to apply this concept in this problem, and you'll see how easy this problem becomes. Okay, so what I want to do is, let's call this particle 1, let's call this particle 2. I want to observe particle 1 from the frame of 2. Okay, what do I want to do? I want to observe particle 1 from the frame of 2. So can I say V12 is equal to V1 minus V2? Do you agree? Okay, and what we are talking about are the initial velocities. V12 will be equal to V1 minus V2. Or we can say this is going to be V1 plus the negative of V2. Okay, so what we are going to do is we are going to change the frame. Now what is the frame? This is the frame. So understand that now the camera is on 2. Whatever we are going to observe, we are observing it from the camera fit on the particle 2. Okay, chalo. Now from here, what will be the initial velocity, or what will be the initial relative velocity? It will be the initial velocity of particle 1. Do you see that? The initial velocity of particle 1, which is u at an angle of 60 degree, plus what we have to do is we have to take the initial velocity of particle 2 and reverse it, minus v2. So we are going to take the initial velocity of the particle 2, reverse it and add it to the velocity of 1. Do you agree? Okay, we are going to reverse it and we are going to add it to the velocity of particle 1. That is going to give us the velocity of particle 1 with respect to 2. Okay. Now what is the initial velocity of particle 2? The initial velocity of particle 2 is 0, which means that this u is the velocity of 1 with respect to 2. Do you agree? This is the initial velocity of particle 1 with respect to 2. Is that correct? Is that absolutely correct? Okay, now here comes the game changer. Now particle 1 is a projectile, which means it is a motion under gravity, and particle 2 is also undergoing motion under gravity. Both of them are going to have the same acceleration g. So if I ask you what is their relative acceleration, you are going to tell me g minus g, and that is going to be equal to what? That is going to be equal to 0, which means there is no relative acceleration. Even though the individual particles have acceleration, the relative acceleration is 0, which means our conditions for collision are met. What is the first condition? That their relative acceleration should be 0, which means that the relative velocity is going to be constant, and if they are colliding, what will it appear to particle 2? The relative velocity will be in the direction of the line joining the two particles. So this, if we extend, is going to be a straight line joining 1 and 2. So this is the relative velocity of particle 1 with respect to 2, and it is going to be along the line joining the two particles. Is that correct? From here it becomes very easy to see that this we had figured out. The value of x we had already figured out. What is the value of x? Let's check. The value of x was 40 by root 3 meter. So value of x we have already figured out is 40 upon root 3 meter. Now just look at this triangle. Just look at this triangle. From this triangle, can we see that tan 60 degree will be equal to h divided by 40 by root 3? Can we say that? Of course we can say that. Now what is tan 60 degree? It is root 3. So this will be equal to 40 into divided by root 3, and this will be the value of h. So the value of h comes out to be 40 meter. Is that correct? Okay, is that absolutely correct? So now you can see that by using this concept, this question was solved in such a small time span. This question was solved so easily if you understand this concept well. Is that correct? Alright, so this is done, and this is a question, or this is an example to show you how to solve questions faster using the condition for collision. Alright, so this is done, and now we can proceed to our next question. Alright, this is the next question. Two particles A and B start simultaneously from the same point and move in a horizontal plane. A has an initial velocity u1 due east and acceleration a1 due north. B has an initial velocity u2 due north and acceleration a2 due east. So different velocities in different directions, and they have different accelerations in different directions as well. Now which of the following statements are correct? So this is a multiple option correct question. So we'll have to use, or we'll have to check each and every option. Alright, what is the first option? Their paths must interact at some point. Okay. What is the second option? They must collide at some point. What is the third option? They will collide only if a1 u1 is equal to a2 u2. Okay. And if u1 is greater than u2 and a1 is less than a2, the particles will have the same speed at some point of time. Alright. Now to be clear here, there is relative acceleration over here. Do you agree? There is relative acceleration over here, but still the particles are colliding. Okay. So the concept we learned earlier, we cannot apply it over here. Can you see that? The concept we learned over here was when there was no relative acceleration, but now there is relative acceleration. So just to make it clear, I'm showing you this example that the previous concept we learned is not the same concept. But anyway, they are colliding, okay? And this is part of kinematics, so we can for sure solve it. Okay, so let's try to understand what is going to happen. So first what I want to do is, I want you to look at the motion of A. Now it has a velocity in the east direction and it has a acceleration in the north direction. So for simplicity, I am taking this as x-axis, I am taking this as y-axis. The east direction I am taking as x-axis, the north direction I am taking as y-axis. Okay. Now for particle 1, the horizontal displacement, what will happen to the horizontal displacement? The horizontal displacement is going to be u1 into t, because there is no acceleration in, not horizontal, this is x direction. The acceleration in the x direction is 0 for particle 1. Okay, just consider particle 1. The acceleration in the x direction is 0. So x1 will be equal to u1 into t. And what will be y1? What will be the displacement along the y direction? There is no initial velocity in the y direction. So this is going to be half into a1 into t square. Do you agree? So we already know this kind of equation. So if we find y1 as a function of x, we are going to get a parabola. Do you agree? So if we write y1 is equal to half into a1, and in place of t we can substitute x1 by u1. So this becomes x1 square upon u1 square. So what is this? This is a parabola. Do you agree? This is simply a parabola. Correct? So the trajectory of the particle, how would the trajectory of the particle look like? The trajectory of particle 1 is going to look something like this. Do you agree? That is going to be the trajectory of the particle. Correct? Now the same things we can do for particle B also. Can we do that? We can do the same thing for particle 2 also. Okay. So for that, how would the trajectory look like? Okay. Now it has an initial velocity, particle B has an initial velocity along the y-axis. Okay. And its acceleration is along the x-axis. Okay. So can we say that y2 will be equal to what? Y2 will be equal to u2 into t, and we can say that x2 will be equal to half into a2 into t square. So from here we can say that x2 will be equal to half into a2, and in place of t square what can we substitute? We can substitute y2 square upon u2 square. So what do we get? We get x is equal to some constant into y square. Okay. So this is again a parabola. But what kind of parabola? The x and y axis are interchanged. Can you see that? The x and y axis are interchanged. So what will be the trajectory of this particle? The trajectory of this particle, and I'm showing it in a dotted manner, is going to be something like this. Which means that at some point it is necessary that the particles will cross each other's path. Okay. So the particles are going to cross each other's path at some point. Is that correct? Okay. So option 1 will be absolutely correct. Is that correct? Any problem here? All right. Perfect. So option A is sorted. Now let's talk about option B. In option B, we were discussing that the particles must collide. And option C was saying that there is a condition under which the particles can collide, otherwise they cannot collide. Okay, so let's think about that. When are the particles going to collide? The particles are going to collide when the displacement of both the particles becomes the same. Do you agree? The displacements of both the particles become the same. In that case, they are going to collide. Correct? So let's talk about the displacement of particle 1 in the x direction. The displacement of particle 1 in the x direction is going to be u1 into t. Do you agree? Okay, so because there is no acceleration of particle 1 in the x direction. Okay, I'm again drawing this axis, x and y. Correct? Okay. Now, what is the displacement of particle 2 in the x direction? It has an accelerated motion and it does not have any initial relative velocity along the x direction. So this is going to be half a2 into t square. So what is this going to give us? This is going to give us either t is equal to 0 or t is equal to 2u1 divided by a2. And t2 is equal to 0 means they are both at the same initial position, which is true. So t will be equal to 2u1 upon a2. If their x displacements match, then t should be equal to 2u1 upon a2. Okay. Now if they are colliding, their y displacement should also match. So let's equate their y displacements. The displacement of particle 1 in the y direction is going to be half a1t square, and the displacement of particle 2 in the y direction is going to be u2 multiplied by t. So we are going to get t is equal to 0, or t is equal to what? T is equal to 2u2 divided by a1, right? Now if at the same time they are at the same position, this is known as collision. So they have to be at the same position at the same time, which means the time that we have calculated should be equal. And what is the time we have calculated? 2u1 upon a2 should be equal to 2u2 upon a1. And from here 2 and 2 gets cancelled, and we get u1 a1 is equal to u2 a2. Is that correct? So if this is the condition satisfied, only then the collision is going to happen. Otherwise collision is not going to happen. Is that correct? Okay? So option B will be wrong. Why? Because it is not necessary they are going to collide. Only if this condition is satisfied, then they are going to collide. Okay? So let's go back and check the options once. So option A, we have figured out that that's correct. Option C, we have figured out it's correct. Now let's look at option D. Now if u1 is greater than u2 and a1 is less than a2, then the particles will have the same speed at some point of time. Okay, so now what we are comparing? We are comparing speed. Okay. So we can say that the speed of particle 1 is going to be particle 1's speed in the x direction, the square of that, plus particle 1's velocity in the y direction, and the square of that, and the under root of that. Is that correct? This is going to be the velocity 1. This is going to be the speed of particle 1. Okay. Now its velocity in the x direction is not changing because there is no acceleration in the x direction. So this will remain u1. So this becomes u1 square. What will be the velocity v1? The velocity v1 will be equal to what? It is going to be equal to u1 plus a1t. The velocity of the particle 1 in the y direction is going to be u1 plus a1t. I'm sorry, its initial velocity in the y direction. Initial velocity of the particle 1 in the y direction, which is what? Which is 0. So this is simply going to be a1 into t. So this becomes u1 square plus a1 square t square and the under root of that. Do you agree? So this is the speed of particle 1 at a certain instant. Now similarly, we can find the speed of particle 2 at the same instant. Okay, now whatever we have done for particle 1, we can do it for particle 2. So this will be, and you can see this very easily, this is going to be u2 square plus a2 square t square. Now when we are saying that v1 is equal to v2, what are we implying? We are implying that u1 square plus a1 square t square should be equal to u2 square a2 square t square. From here what we can do is we can find out what is t. So t is going to be u1 square minus u2 square divided by a2 square minus a1 square and the under root of this. Okay. Now if their speeds become equal, then their speeds are going to become equal at this time. Now if actually their speed becomes equal, then time should be real. Do you agree? If actually their speeds are becoming equal, then time should be real. Now if time should be real, then whatever is in the under root should be positive. Okay, it should be positive. Now what is given to us? It is given to us that u1 is greater than u2. So the numerator is positive and a2 is greater than a1. So the denominator is also positive. So positive upon positive is going to be positive. Hence t will be real, which means actually at some point of time their speeds will become equal. Okay, so we can say that option D is also going to be correct. So what will be our correct options? A, C and D. Is that correct? Alright, so that is this question. So I introduced this question. The objective of doing this question was to differentiate between the condition of collision. Whatever we discussed, the condition for collision it is under zero relative acceleration. But if there is relative acceleration, you cannot apply that. Okay, in that you'll have to use your concept of 2D motion. All right, perfect. Chalo, let's then go for the next topic. The next topic is distance of closest approach. So first I'm going to explain this in principle, and then I will sort of solve a question to explain that further. Now, if two particles are not colliding, okay, if two particles are not colliding, then their paths would cross, okay, their paths would cross. And if their paths are crossing, then there will be some instant at which the two particles are at the minimum distance. Okay, so let's try to understand that. So suppose there is this particle V1, which is at an angle of theta 1, and let's say this particle is has a velocity V2, and it is projected at an angle of theta 2. Now this motion can take place both in a horizontal plane. Okay, if it is taking place in the horizontal plane, then both of the particles do not have any acceleration. It is happening in a horizontal plane, so they don't have any acceleration. So the relative acceleration is going to be 0. Okay. Now if it is happening in the vertical plane as well, then the both particles are projectiles, which means their acceleration is g. In that case also there is going to be no relative acceleration, correct? So if we observe one particle from the frame of other particle, we'll see that it's a constant relative velocity. And if it is a constant relative velocity, then the trajectory of the particle is going to be a straight line. Is that correct? So what I want to do here is, I want to observe particle 1 from the frame of particle 2. Okay? So I'm going to observe particle 1 from the frame of particle 2. So velocity 1, 2 will be equal to velocity 1 minus velocity 2. Or I can also write it as, we can put the vector signs also, we can also write it as velocity 1 plus the negative of velocity 2. So if I have to observe this, now this is ground frame. Okay, what you're seeing is ground frame. Now I'm going to show you how it is going to look from the frame of 2. This is 1, this is 2. Okay, how it is going to look from the frame of 2. So from the frame of 2, 2 is not going to have any velocity. What will be the velocity of 1? It is going to be V1. So V1 is like this. And then what do we need to do? We need to invert the velocity of V2. What is this? V2 is like this. So we need to invert the velocity of V2 and then add it to V1. Okay, so we have inverted the velocity V2 and we are going to add it. So this is going to be V2 and this is going to be theta 2. Is that correct? Is this clear? So 2 is going to see the velocity of 1 like this. Do you agree? 2 is going to see the velocity of 1 like this. Which means that if we find the resultant of these two vectors, let's say this is the resultant of these two vectors. Okay, let's say this is the resultant of these two vectors. So particle 2 will see that it has a constant velocity. And if it has a constant velocity, then its trajectory is going to be a straight line. So particle 2 will see that this particle 1 is going to go along a straight line like this. Is that correct? So that will be the trajectory of particle 1 with respect to particle 2. So where is the particle closest to particle 1? Okay, so if we drop a perpendicular, then this distance, let's call it h. This distance is going to be the distance of closest approach. At this point, or at this distance, the particle 1 was closest to particle 2. When particle 1 is over here, the distance is larger, the distance decreases, and then again, the distance starts increasing. Is that correct? Okay, so this is how we are going to calculate the distance of closest approach. This is the basic concept. Clear? Alright. Now if this is clear, then we are going to solve a question to understand this further. What is the question? There are two cars A and B are moving west to east and south to north. Okay, so this car is moving, A is moving west to east and B is moving south to north. A moves with a velocity of 20 meter per second and it has a distance of 500 meter away from an intersection. This is the intersection. So at this instant, the particle A or the car A is at a distance of 500 meter. Now car B is moving with a velocity of 15 meter per second and it is at a distance of 400 meter from the intersection. Find the shortest distance between them. Okay. So if it is given in the question that find the shortest distance, then we can assume that there is going to be no collision, or if there is going to be collision, we will figure that out. Okay, but for now we can assume that there is going to be no collision, but then car 2 is going to cross like this, the car B is going to cross like this. So there is going to be some point at which the cars are closest to each other and we need to find out that distance. Okay, again the concept is not going to change at all. The concept is going to be exactly the same. Okay, what do we want to do? So we want to observe car B from the frame of car A. Okay, we want to observe car B, or you can do the opposite way also. That also works. Okay, you can do it the other way also. That is also going to work absolutely fine. So what I'm going to do here is I'm going to observe car B from the frame of A. All right. Chalo. So if I'm observing car B from the frame of A, I can say that velocity BA is equal to velocity B minus velocity of A. But then I can also write it as velocity of B plus negative of velocity of A. Is that correct? Okay. So now I am in the frame of car B. Now you are in car B. You are observing everything from car B. Okay. So your velocity will not be seen. You cannot see your own velocity. Is that correct? Okay. But how would you see the velocity of A? So velocity of, oh I'm sorry, we are observing it from the frame of A. Very sorry about that. We are observing from frame A. So frame A, the velocity of A with respect to A will not be seen. Correct? Okay. So now from this frame, you are in car A and you are observing car B. What is the velocity of car B? Car B velocity is velocity of B plus the negative of velocity of A. What is velocity of B? Velocity of B is this. What is that? That is 15. Do you agree? This is velocity of B, 15. And what is velocity of A? It is 20 in this direction. 20 in what direction? In the east direction. So first we need to invert that. So we have inverted that and then we have added it. So what is this going to be? This is going to be 20. Do you agree? This is going to be 20. Alright. So the resultant of these two velocities is going to go something like this. The resultant is going to go something like this. Is that correct? Okay. Can we figure out what is the angle at which they are going to go? Okay, that is going to be critical. That is going to be critical. So I want to figure out what is the angle at which they are going to go. So I am talking about this angle. Let's call this angle theta. Let's call this angle theta. Okay. So can we say that tan theta is equal to 20 upon 15? Okay, this is the resultant velocity. And we can say that tan theta is equal to 20 upon 15. Tan theta is equal to 20 upon 15, which is 4 by 3. What is this angle? This angle is 53 degree. Okay. Now what we also need to figure out is, now this is the position of car A. Whether this velocity is going to go like this or whether this velocity is going to go like this. That is something that we need to figure out. And how are we going to figure out? If we are able to find this angle. So I'm going to change the color of the pen and join these 2 points. Okay, I have joined these 2 points and I want to find out this angle. Okay, I want to find this angle. What angle is this? This we can say is alpha. So tan alpha will be equal to what? Tan alpha will be equal to 5 by 4. Here tan alpha was 4 by 3. So 4 by 3 is what? If you calculate 4 by 3, what is it? It is going to be 1.3 something. Correct? It is going to be 1.3 something. And what is 5 by 4? 5 by 4 is going to be 1.2. Correct? So which angle is greater? Obviously theta is greater. Is that correct? Obviously which angle is greater? Theta is greater. Alright. So now what I'm going to do is I'm going to put it on another diagram so that it doesn't become very clumsy. Okay, but this is clear, right? Tan theta is 4 by 3. And what is 4 by 3? 4 by 3 is 1.3 something. And what is tan alpha? Tan alpha is 5 by 4, which is 1.2. And theta is an increasing function in the first quadrant, which means that 53 degree is going to be greater than alpha. Okay, so the particle is going to go something like this. Do you agree? The particle is going to go something like this. Is that correct? Okay. So how do we calculate the distance of closest approach? Let's extend this. Okay, let's extend this. So according to car A, this yellow line that you see, according to car A, this yellow line is the trajectory of particle B. Do you agree? This yellow line is the trajectory of particle B. So if we drop a perpendicular over here, then this distance, let's call it PQ. Then this distance PQ is going to be the distance of closest approach. And we want to find that distance. Is this clear? Alright, is this absolutely clear? Any problem over here? I hope this is perfectly clear. Alright. Velocity of B with respect to A, just checking if we have done the calculation right. So this is the velocity of B with respect to A. So that is velocity of B, which is 15 meter per second, and velocity of A, which is 20 meter per second, right? Chalo, let's move forward. Let's move forward and try to solve this. So this is PQ. Now this angle we already calculated, okay? This angle we had already calculated. What is that angle? That angle was 53 degree. Which means if we look at the large right angle triangle, this angle is going to be what? This angle is going to be, what is this angle going to be? This angle is going to be 37 degree. Is that correct? Okay. So from here, what is it that we calculate? If we calculate that, we will be able to get the distance PQ. Okay, so what we are interested in is, we are interested in finding this distance. Do you agree? We are interested in finding this distance. Let's call this distance X. Now I want you to concentrate on the larger triangle. So can I say tan 53 degree is going to be 500 plus X divided by 400. Okay, just concentrate on the larger triangle. Let me draw that for you if you are not able to see that. Okay, just concentrate on this larger triangle. So tan 53 degree would be equal to what? Tan 53 degree will be equal to 500 plus X divided by 400. So this is 4 upon 3. This is equal to 500 plus X divided by 400. So this becomes 1600 is equal to 1500 plus 3x. And so from here, what do we get? We get 1600 minus 1500 is equal to 100 divided by 3. This is equal to x. Is that correct? So what is x? X is equal to 100 divided by 3. Do you agree? Okay, so tan 53 degree is equal to this distance 500 plus x divided by 400. And so from there we got 1600 is equal to 1500 plus 3x and x is equal to 100 by 3. Is that clear? Now what is this distance PQ? If you look at the smaller triangle now, which triangle? Let me show that again. Just look at this smaller triangle. It's again a right angle triangle. Okay, so what is this distance PQ going to be? This distance is going to be x sine 37 degree. This distance is going to be x sine 37 degree. So this becomes 100 divided by 3. And what is sine 37 degree? Sine 37 degree is 3 by 5. So this comes out to be what? This comes out to be 20 meter, and that is going to be the distance of closest approach. Is this clear? Alright, so nothing very difficult about it. Obviously there is some part of calculation over here, but the numbers were such that everything was easily cancelled out and we had the answer as 20 meter. But do you understand the concept of distance of closest approach? What is the crux here? That you need to observe the velocity of one particle with respect to the other. So the first particle is going to be at rest and the relative velocity of the second particle is going to be a straight line, and you're going to draw that trajectory. The perpendicular on that trajectory will be the distance of closest approach. Now remember here that there is no relative acceleration. Because there was no relative acceleration, the trajectory of the second particle with respect to the first was a straight line. Otherwise, it would have been parabola and the concept would not have been applied over here. Okay, so be wary of that fact, where you can apply this concept, where you cannot apply this concept. So for both condition for collision as well as the distance of closest approach, you can only apply it when there is no relative acceleration. Alright, so I'm going to wrap this up over here and I'm going to come again at 5 o'clock and we are going to discuss some very good practice problems on this topic. Okay, so do tune in at 5 p.m. again and I'm going to see you there. Alright, so till then, keep practicing, keep getting better, and remember, you guys are rankers. Thanks for watching.